I'm Ed Munyak, licensed fire protection engineer for at least 25 years, and I work for a number of organizations, city, federal, large insurance companies, consultant, always in the area of fire safety, and with the goal of keeping the public safe and first responders safe. And at present, I'm working in the city of San Jose as a fire protection engineer. And we strive to ensure that buildings are built in accordance with the state of California standards for structural strength and the proper exiting, so that people can get out quickly and safely from a building under all conditions. Well, I became fascinated with the government's version of the events on 9/11, because this is totally contrary to everything that I've ever experienced, either working in the field of fire safety or knowing what I know about mechanical engineering. It defies many fundamentals of mechanics of materials and physics and just many fundamental engineering concepts. And I just needed to resolve some of these inconsistencies in my own mind. And so I undertook a study of high-rise buildings, that the history over the last 20 or 30 years. And there's been a number of major high-rise fires. And what I found that nothing has ever been close to structural performance that was exhibited on 9/11. And even one collapse, progressive global collapse, as they call it, would have been extraordinary. But to have three occur in one day was just beyond comprehension. And so I even went so far as to go to the UK and investigate some of the tremendous research they did. They built huge fires in abandoned buildings, and they placed enormous fire loads in the buildings, much more than they're debating about in World Trade Center 1, 2, or 7. They purposely loaded the fire, the amount of combustibles into these buildings. They just let the fire rip, and what they found was the steel distorted and sagged, and in some cases beams sagged 3 or 4 feet down into like a clothesline shape, because they lost their rigidity, and the temperature went above the limits where they're normally comfortable in working with, and yet they were still relatively strong. The catenary shape of a sagging beam was actually fairly strong. The beams got more elastic. They were able to deform, and in the process of deforming, they absorbed huge amounts of energy. So in looking back at the NIST report, the media portrayed these fires as being extremely hot, but in going into the NIST reports with a licensed chemical engineer who normalized all the data, the fires were not that hot in World Trade Center 1 and 2. And if you look at the NIST zone data, you could see this. And to use our own powers of observation, you could tell by seeing these fires, seeing black smoke come out the windows, that means that the fires were oxygen starved. So the heat did not reach the temperatures that it could have reached if all this black soot actually burned. The fuel just sort of gave up heat to vaporize some of these constituents into black smoke, and it was incomplete combustion. And so it was a low temperature fire. And that was obvious by looking at the pictures, seeing the black smoke. But in other high-rise fires where there was vertical openings, broken windows, there was a free flow of oxygen in, and these fires exhibited a whiter smoke plume, very little dark carbon, because it was more complete combustion, much hotter. All the other high-rise building fires that were significant, in other words, where the fires spread vertically upward, the flames would shoot horizontally out the windows. They'd bust the windows. That radiant heat would then ignite the floor above. That would start burning, and so on. It would work its way up the building, and in some cases, this went on floor by floor for hours and hours, and it's just radiating heat, glass shattering, and fire spreading. And ultimately, the whole contents of a high-rise building would be consumed in a much hotter blaze. And so, like, for instance, the first Interstate Bank building in Los Angeles, California, that was quite a robust building because it was built in a seismic area. But it had insufficient blockage to prevent the vertical spread of fire. So fire spread top to bottom, and that fire burned for 4 hours. Very hot fire. But at the end, there was no structural damage to the first interstate building. And that was a major high-rise building in Los Angeles. There was no insurance claim for repairing the structure. A lot of damage on the finishes, but not the structure. While in the fire in Philadelphia, that was also a very long fire and a tremendous fire load in that because of construction materials. That did warp the steel frame, and it was a huge battle with the insurance companies to see who was going to pay the damage because the steel was warped. But the building stood. It didn't collapse like a house of cards, and it didn't. Nothing happened. It just warped the steel, and that's what they found in the UK when they tested under extreme fire load conditions. Beams sagged 3 or 4 feet. The columns mushroomed, and they found that the time when beams did exhibit some cracking and failures was when things cooled down. So you had a clothesline catenary shape, and as it cooled, it wanted to straighten out to its original flat surface again, and it couldn't. And so it cracked at the joints between the vertical and the horizontal. But still, the building was an indeterminate structure, and they held up. So there was cracking, but there was enough redundancy in the structure, as all high-rise buildings are built with redundancy, that they just don't collapse, as NIST said. And the conclusion of the NIST report was that a single flaw occurred, and that cascaded and progressed very quickly, so the whole building collapsed. And that just isn't the way the way buildings are designed or the way the experience has shown. The staff engineers, scientists that contributed to the NIST report had some good information, and they show that the jet fuel for a few moments it was a hotter fire than would normally be experienced in the standard time temperature curve for fires. But that quickly dissipated, and the overall effect of this jet fuel in the total duration of, say, 0 to 1 hour, or just before the buildings collapsed, was relatively insignificant. The difference, maybe it was 5 or 10% more BTUs in the whole floor area. But that's, in the whole scheme of things, it's insignificant, because the fire loading could be increased by a factor of 10, and this still wouldn't have been a difference as far as the building surviving. The building has a huge thermal mass, and the energy of the fire is really not that great compared to the thermal mass of the building. It just takes a huge amount of energy to heat all that steel and concrete up. And if you look at it, step back and look at what was going on, the effect of the jet fuel was relatively short-lived, few minutes, and then it didn't add anything extra to a normal fire. A normal office building fire will burn out in about an hour per floor. In other words, the contents get consumed, and after about an hour, there's no fuel left to burn. So everything just sort of decays in temperature and heat. So when the first World Trade Center collapsed, the fire was still, it was just about peaking out, and it may have even started to decay at that point as far as the heat. But still, it wasn't even, from what I have calculated with a registered chemical engineer, it did not meet the magnitude of a standard time temperature curve, which is how buildings are rated. When the planes made impact, the fuel that was in the tanks of the aircraft was instantly atomized, and that was like a blowtorch on those first and second floors. That it blew a lot of the office contents right out the other side of the building, so that reduced the fuel load right there to some extent, and it was a hotter fire for maybe a couple minutes. But if you integrate that heat input over time, overall it was less. It was less than the standard time temperature curve that structures have to meet when they're tested by underwriters' laboratories. The standard fire test is quite stringent in that it assumes a very rapid heating of the structural steel, but in the case of a big high-rise building, well, you have much more of a massive structure that has to be heated up, and so that's why overall it wasn't much of a high challenge fire for that structure compared to, say, a one-story building with a thinner structure that would still have to meet basically the same fire test, but to get that same structural temperatures, it takes a huge fire, and it just the combination of the normal office fire loading and this extra input of jet fuel for that initial spike, it still didn't add up to a very significant fire load, nor a very significant fire. And we could see that by, again, looking at the evidence. The fire did not spread vertically in World Trade Center 1 and 2. It didn't spread from up above the impact floors. It more or less stayed there because it was a pretty well designed building. It didn't have gaping vertical holes like so many of the other high-rise buildings that had structural defects where they had large vertical openings that allowed much more air to get in and mix with the available fuel that results in a much hotter fire. And so it just wasn't that hot a fire in relative terms compared to other high-rise buildings, historically speaking. One of the really interesting photos that sticks in my mind, other than the collapse itself, is a picture of a young lady. She's standing. Edna is standing at the lower opening, this gash in the side of the World Trade Center, and her stature, her body language is one of, "I'm safe here. I'll just wait to be rescued," because the air was rushing in at her back, so it was relatively cool. She's standing unprotected, no protection from the heat at all, and this was moments before this thing came crashing down with her and approximately 400 or 500 more first responders in that building, and they all had faith that this building was not going to come down. Just like the fire department fought bigger fires in the World Trade Center in previous years. And they knew the building is not going to come down from this fire. And they tried to fireproof the unprotected steel in the World Trade Center 1 and 2 as an afterthought. And they used a mineral to apply this basic insulation to the steel. As it turns out, this mineral, a lot of it is from Libby, Montana, and the W.R. Grace Company developed this product called Zonocoat, and it had a high percentage of asbestos in it. And so in the building, there was tons of asbestos in World Trade Center 1 and 2, and if they were to remediate that building in a legal way, in other words, chip away all that asbestos fireproofing, scrape it off, and haul it away to a licensed asbestos storage facility, it would cost an enormous amount of money, probably more than the building was purchased for. So again, we have a red flag of arson. In addition to the multiple fires in World Trade Center number 7, you have a profit motive. In World Trade Center 1 and 2, the fact that to remediate an asbestos-laden building in Manhattan the cost would have been astronomical. This was a massive structure, 57, I believe it was 47 stories tall. That's a huge building, even though in downtown Manhattan it was dwarfed by other buildings, but the structure is massive. And again, no high-rise building has a single link that when it fails, the whole building comes down. Registered architects, engineers, designers, even the greediest developer would never build a building that would come down with one single link breaking. What they did in the UK was take steel frame buildings, unprotected, not insulated, and they set huge fires in them, and nothing collapsed like that. These were old steel buildings. They just simply sagged, columns mushroomed and got thicker, and in the process, all this energy was absorbed. The energy of the fuel was absorbed by the deformation of that steel, and that takes a lot of work to displace that steel in various directions, up, down, sideways, tension, compression, torsion. That's all absorbing the energy from that combustion, and nothing happened in the UK. Tremendous heat and sagging beams, and that's all. So it's fiction to say that a building as modern as World Trade Center 7 comes down with no resistance, a free fall, which is that's been measured. Just about the same speed as a hunk of iron dropping, and that's just ludicrous. The beams expanded. Well, they will expand when heat is applied. That's a natural phenomenon. But again, as they expand, the whole structure absorbs this strain energy, and it distorts. And actually, as the temperature of the steel gets warmer, it actually absorbs more and more energy because it's able to flow in a semi fluid sort of a way, and so the steel distorts and expands, but there's enough redundancy where really nothing dramatic will happen. And if it happens, it will happen when it's cooling down. That's when you get the differential movement, and things are starting to get more cooler and more rigid, and then that's when the cracking starts. But even so, that cracking is localized, and it doesn't bring down the whole structure. Firefighters know when they go into a building, they're not foolhardy. They're brave, but they're not foolhardy. They wouldn't go into a building that they know is imminently going to collapse. And so they had they knew in their hearts and their minds that this building was not going to collapse. Something else was going on. So after studying the history of high-rise fires and seeing how these three events on 9/11, how they would fit into the continuum of damage from a fire, they're just so far out of the realm of fire history. We need an unbiased investigation to look at these the results, the raw data that we have available. And it's unfortunate that the evidence, the structure was scooped up and recycled, because they were a gold mine of information to really do a thorough investigation of what happened here. It was contrary to the way all investigations are done. If an airplane crashes, they seal off the entire area. Nobody touches anything. They move it to a secure location, and they reconstruct an aircraft. In this case, everything was scooped up, and all of a sudden they had a big incentive to recycle steel for some reason, and they just recycled it as quickly as they could, and it was a tremendous error, or whatever you want to call it, that this steel was hauled away and melted down before it could be analyzed. Because here we have architects and engineers in this country have a tainted reputation that we build buildings where if a single element fails, the whole building comes down. At least that's what this says. And this is totally untrue. So we need to seek the truth in this and not have it run by political appointees from the powers that be in Washington.